Hi everyone. Today we'll take a look at a new concept in permutation combinations called bundling items. Okay, so bundling items is a very common type of questions that you can come across in the IB as well. Again, they have more or less a standardized approach unless and until they ask something really out of the box. But then again, you really shouldn't worry, because let's say if it's a 5-mark question or a 6-mark question, you will, if you approach it and if you begin the question in the correct fashion, then you can always expect 50% of the marks to be rewarded, right? You might lose the last 1 mark for not from probably missing the one aspect they want to consider, but otherwise you can get a decent amount of marks out of these questions as well. Okay, so very simple bundling items. Let's say you have 5 books, 5 let's say, I don't know, Percy Jackson books, 3 Harry Potter books, and let's say 2 Roald Dahl books. Okay, Roald Dahl, maybe like Charlie and the Chocolate Factory and something else. Okay, so Roald Dahl books. And your librarian, you have to arrange them, or you have to select some books out of them. And how can they be done? And then how can they be arranged within themselves as well? Maybe let's say no Percy Jackson books should be together, no Harry Potter books should be together, something like that. All these sorts of things can be asked. Loads and loads of questions can actually be generated out of them. Okay, so let's start with an example question that we have right here. It says a library has 3 mathematics. Okay, let me change the color. Okay, it doesn't matter actually. 3 mathematics, 2 physics, and 5 chemistry books, which are to be arranged on a shelf. In how many ways can they be arranged such that all books of the same subject are together? Okay, so the mathematics should always be together, physics should always be together, and chemistry should always be together. Now, 2 considerations. Okay, first is the book of the same subjects are identical. Okay, now what they mean in this first case, what do they mean? What they mean is that 3 mathematic books, they may perhaps be pre-algebra, algebra. They can be algebra 1, and maybe calculus. Okay, like this, something like this, maybe. Right? Let's say that these are the 3 mathematic books. In this first scenario, we consider all of them to be the same. We don't value one over the other. They're all just mathematic books for us. Okay, so if that's a situation, what we do is we actually club each subject together. So we have mathematics. Okay, and we club them together like this. Then we have 2 physics, let's say 1 for maybe thermodynamics, 1 for fluid mechanics. So the 2 physics books are like this, and then the 5 chemistry books. So let's say we have stoichiometry, thermodynamics, let's say biochemistry, and you can medicinal chemistry, and maybe I don't know, surface chemistry, material science. Okay, something like this. So we have 3 distinct subjects, and we're just arranging them based on that. So this itself is one, this itself is 1 unit, and this is one. The chemistry itself is another unit. Total, we actually have 3 units. So the total ways are just 3 factorial ways, or we can call it 6 ways. 6 ways they can be arranged. That's it. Okay, that's literally it. Now, for the second consideration, right? The second consideration asks us where they're all distinct, right? You can say, hey, pre-algebra has its own importance, algebra has its own importance, calculus has its own importance. Let's say, these are for middle school kids, these are for middle school kids, and maybe these are for high school students, okay? Or these are for high school students, and these are for college students, okay? So let's say that the middle school should always be in the left side, high school should be in the middle, and calculus should be on the right side. Like a chronological manner. Let's say the librarian wants it done that way. So that gives the books meaning, right? That gives it meaning. That means that okay, this order does matter. Okay. So what I'm going to do is I'm going to give them subscripts. Okay. So I'm going to call it M1, M2, and M3. So this is 1 section. Again, there are together, that's why I'm bundling them up. Okay, let's say we have physics 1 and physics 2, like this. All right. And then we have chemistry 1, chemistry 2, chemistry 3, chemistry 4, and chemistry 5. Again, all bundled together. So we're going to have, by default, the 3 factorial, right? Let's say this math were to be between physics and chemistry, so if this were to go here, that's a 1 permutation and all sorts of those things, right? So we have our 3 factorial for the big bundles, right? The big bundles that I've the box that I've drawn around, right? Then we're gonna have the individual permutations, the individual arrangements of the math books. So there are 3 math books, so they can be multiplied by 3 factorial ways. Similarly, physics have 2, so that's 2 factorial. And chemistry has 5, so 5 factorial, right? So this is our solution, and you can multiply it out. This is 6 times 6 times 2 times, I think, 120. So this gives us it's a pretty big number, 36 times 240. I'm not gonna solve it, but you get the idea. Okay, so 36 times 240, whatever that comes out to be, that's your answer. Okay. I feel this is kind of straightforward, so let's go to the next question now. All right, very similar. We have a library has 3 mathematics, 2 physics, and 5 chemistry books, which are to be arranged on a shelf. In how many ways can these be arranged such that mathematics books are together? Okay, same thing as the previous thing, but this time only the mathematics books are together. Only the math books are going to be bundled together. Okay, so our initial situation can be kind of like math. So this is one entity of itself, and then we have your 2 physics, and then chemistry 1, 2, 3, 4, 5. Notice that I didn't put the subscript for the first case because they're identical. Okay, they're not different from each other. Let's say I have 3 pre-algebra books, 3 fluid mechanic books, and 5 stoichiometry books. That's why whether I put this one before the second one before the first, doesn't matter because they're the same books, right? Doesn't matter. Okay, so now how many ways can this actually be arranged? That's the key question. Okay, so there are total 8 entities, right? Let me take a different color and I'll show them. This is 1, 2, 3, 4, 5, 6, 7, 8, right? 8. Okay, so what I'm going to do is I'm going to do it similar to what I did in the second video of permutations, I believe. So you have your 8 factorial are the total ways they can be arranged. Remember, but physics is repeating 2 times, so I'm going to divide it by 2 factorial. Just like I did for physics, I'm going to do it for chemistry as well, for 5 factorial. Now notice I don't do it for the math. I'll tell you why. Because I've treated math as an individual entity. Think of it as 3 M's make one big M right here, like this. And they're one entity of itself, and we don't care what happens at the inside because anyways we know the books are identical. So our final thing, what we're left with is 8 factorial by 2 factorial what we're left with is 8 factorial by 2 factorial by 5 factorial. Okay, super simple, nothing too crazy. You can simplify this on your own if you want. I can just write it down. So you'll have 8 times 7 times 6 times 5 factorial by 2 times 5 factorial. So this cancels. You have 56. I could call it 56 times 3. It's kind of like 150 plus 18, giving us 168. Okay. Let's do the second question. I think I have space on the right side. Okay, so I have space here. Okay, same question. The only thing is that now each books are distinct. Okay, so I'm going to write them as distinct. So I'm going to write this M1, M2, M3, P1, P2. However, I'm still going to bundle up the math. Okay, I won't forget because the math books have to be together. Okay, and then we have C1, C2, C3, C4, C5. Okay, again, let's count up how many total entities do we have. Well, we have 1 for the math, 2, 3, 4, 5, 6, 7, 8. Okay, so we have a total of 8 factorial ways. However, this is fine. This is all perfect. We can stop here. But remember that these math books in and of itself can be arranged, right? This can be M2, M1, M3. It can be, M1, M3, M2, right? So there are 3 books. They can be arranged in 3 factorial ways. Okay, so that's why we're multiplying them, and our final answer is whatever 8 factorial times 3 factorial is. Okay, because this represents for inside the bundle. Okay, inside the bundle. That's why we have to multiply with the possible arrangements of 8 factorial. Okay, again, standard question, nothing too crazy. Let's look at the next one. Now, yes, in the IB you can face questions which have multiple parts to it. So again, this is a good practice as well. Let's change the color. So we have the word imagination be arranged such that both the A's are together, both the A's, N's, and all 3 I's are together, and all vowels are together, and all vowels and all together, and all consonants are together. Okay, so let's list out the letters. Okay, so we have 3 I's, 1, 2, 3, right? 1, 2, 3. 2 A's, 2 N's, and then we have M, G, I think T, and I'll kind of like squeeze an O right here like this. Okay, now the first part is asking us for all A's together, so we can list it out like this: A, same as before. Again, we're gonna take that these A's and I's are all the same, okay? Because remember, if you swap these 2 I's right here, that's the same thing. It doesn't make a difference. It doesn't matter. So we're gonna consider them the same thing, right? Their order really doesn't matter the way I's are arranged. Okay. Same goes for the A's. We don't really care how A's are arranged. They're the same thing, right? It would have mattered if they were books, because books can be distinct and they can not always be distinct. But letters they're always identical if there are multiple of them. Okay, so we have 2 A's, 3 I's, 2 N's, M, G, T, O. Right? So total, let's count it up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 factorial total letters. Again, we have a repetition of 1, 2, 3 I's and 2 N's. Okay, again, I'm not going to put another 2 factorial because I'm treating this as an own entity. Imagine that these 2 A's inside don't even exist. I don't care. I just care about the big box that's outside. Okay, so this is my final answer. Okay, I'm not going to simplify it because I'll basically need a calculator, otherwise I'll just be wasting my time. Okay, next part where both A's, N's, and I's are together. Okay, so same setup as this one. So I'm not going to write it down. You can kind of just visualize it. This is 1, this is 2, this is 3. So I'm left with 1. So I have 1, 2, 3, 4, 5, 6, 7. Right? I have total 7 groups. Okay, 7 factorial. Is there any sort of division that's needed? No, because M, G, T, and O don't repeat. So this is my final answer, 7 factorial ways. Okay, let's see if I have space on the next one. Okay, I have space here. Okay, I'll take orange. And what's the second part? All vowels are together. Okay, so all vowels are together. Then we have the 3 I's. We have, let's say, we have the 2 A's. 1, 2. Okay, we have the O. And then we have your M and the 2 N's and the M, G, T. Okay, so I'm going to bundle this up. Okay, this is third case. I'm going to bundle this up. Okay, this is be bundled up. So now how many total entities do I have? Let's take green. I have 1, 2, 3, 4, 5, 6. Okay, I have total 6 entities, so that gives me 6 factorial ways. However, I have the 2 n's that are repeating, so I'm going to divide by 2 factorial. Right? Now, this is one part. Now I have to consider the part inside the bundle, because remember, there's just not the 3 i's, there's a's and o's as well. So there can be loads and loads of arrangement inside as well. So there are 6 letters inside, so 6 factorial for that. There are the 3 i's, so 3 factorial for that, and the 2 a's, so 2 factorial for that. Okay, so this, remember, is inside the bundle. Okay, inside bundle. Okay, and if I want to try simplifying it, I can. If I want, I have, 6 factorial times 6 times 5 times 4 times 3 factorial by 2 times 2 times 3 factorial. So this is cancels this, this cancels this. So I have 30 times, what is 6 factorial? I think 6 factorial is 720. So kind of, like 72 times, let's say, how does that come out to be? 70 times 3 is 210, so I think 21600. I think I'm just doing it on top of my head. I don't have the answer. I just have this, and I just know that this is the right answer. Okay, so yeah, this was the thing, just a little bit more tricky. One extra consideration to keep in mind is this inside bundle part. Don't ignore this, it's important. Okay, last part. Now the last part says all the vowels and consonants are together. Okay, so essentially I can use the same setup as this. I'll just rewrite it again. So I, A, O. This is one bundle. And then we have N, M, G, T. Okay, so there are 2 bundles that can be done in 2 factorial ways. Let's look at this first bundle. So first bundle will have the same setup as the previous thing, which is basically, you can say 6 factorial by 3 factorial by 2 factorial. And then we're going to have a second bundle, which is 5 factorial. And the only repetition is our 2 n's. And that's it. That's literally it. We just multiply them together, and that's our solution. That's it. Next question. We're asked that 2 families with 3 members each, and 1 family with 4 members are to be seated in a row. In how many ways can they be seated so that the same family members are not separated? Okay, super simple. Okay, super simple. So we have 2 families with 3 members and 1 family with 4 members. So basically we have 3 families in total. Okay, so I can call it family A, family B, and family C. Okay, so these 2 families have 3 members each, so I'll call them A1, A2, A3. Family B has 3, so B2, B1, B1, B2, and B3. And the third family has 4 members, so C1, C2, C3, C4. Okay, so our goal is how many ways can they be seated such so that the same family members are not separated. Okay, so that means we have to bundle them up. We have to bundle up each family. So if we bundle up each family, we have A, A1, A2, A3 bundled up once. Then we can have B1, B2, B3, another family bundled up. And then we can have C1, C2, and C3, C4. Okay, bundled up. So now let's just look at the individual bundles now. Okay, so the individual bundles, there are 3 of them. So the blue, green, and purple, right? They can be arranged in 3 factorial ways, right? Now let's look at the individual, right? Within the family A, well, they're all different people, right? So if A1 is if A2 is in the middle or A1 is in the middle, it matters. It'll change up the arrangement because they're people, right? So now the A family has 3 factorial ways. Similarly, B family B also has 3 factorial ways, and family C also has, but has 4 factorial ways. So technically our solution, we can condense it down to 3 factorial raised to the power 3 times 4 factorial. That's our answer. Again, super simple, nothing too crazy. Alright, so we've taken a look at a lot of bundling questions. Now let's take a look at separating items. Okay, so separating items is basically the opposite of bundling, right? So again, you have a bunch of books, people arranged, and let's say and they don't have to be, they have to be arranged in different ways. They can't be together. Let's say certain people, let's say you have 2 sports teams and you have said, okay, we're gonna alternate every member from the sports team. So one person from the home team, one person from the away team, home away, something like that. Or you have 10 couples and they have to be arranged in let's say male female. How can they be arranged? Okay, so kind of like that situation. Okay, so without explaining, just conceptually explaining a lot of things, let's just do it with the question. Again, same situation as the previous question of bundling type. We have 3 mathematics books, 2 physics, 5 chemistry. They're to be arranged on a shelf. How many ways can be done if only mathematics books are separate? Okay, so mathematics books are to be separate. They cannot be together. Okay, so let's do the first case. Okay, the first case is all the books are identical. Let's say I have 3 of the same math books, 3 of the same physics books, 5 of the same chemistry books. Okay, so in that situation, I basically have, let's say I'll have M, and then I'll have P, C. Okay, so what I'm gonna do is I'm gonna first neglect the books that are supposed to be separate. Okay, this is the standard formula I'm gonna follow step by step every time. Okay, so what I'm gonna have is I'm gonna do basically physics, make a dash, physics, make a dash, chemistry, dash, chemistry, dash, chemistry, dash, chemistry. Okay, so how many chemistries do I have? Okay, perfect. Okay, so I have the 2 physics and the 5 chemistries. Okay, now wherever the dash is, right, my books can go in those spots. Okay, my books can go in that spot. I can squeeze the math books in those situations. Okay, so let's say for example I randomly decide this spot, I randomly decide this spot, and then 2 spots down I decide this one. Okay, this is where my math books are gonna go, and these empty spaces, I'll just bring all the chemistry books together, touching them. Okay, and the physics books. So first, let's just look at the yellow, the ones that we have in physics and chemistry. So there are a total of 7 books of those. Okay, 7 books, and the 2 physics are repeating because remember, in this case, we're taking them to be identical. So we again divide by 2 factorial. Similarly, my 5 chemistry books. Okay, my 5 chemistry books. So how many spots do I have for my math books? I have 1, 2, 3, 4, 5, 6, 7, and 8. So I have 8 spots from my math books, and I have 3 books, or 3. I have to fill in 3 of them, right? So what I do here is I use combinations. Okay, I'm gonna do 8C3. Why? Because I have 8 spots and I have to fill in 3 of them, and I don't care in which fashion they go. That is why the order doesn't matter, because the books are identical. Okay, so what's going to be my final answer? 7 factorial by 2 factorial by 5 factorial. So that kind of comes out to be 7 times 6, which is 42, divided by 2, which is 21, and then I have my 8 factorial by 3 factorial by 5 factorial, which is going to come out to be 21 times 8 times 7 times 6. So 8 times 7, I'll just do 8 times 7, which is 56, because this is going to cancel it out. So I'm left with 21 times 56 ways. Okay, again, the whole idea is first, create the permutations for just the physics and the chemistry books and then multiply it with the empty spots that can be taken up by the math books. Okay, again, this is quite a common question. You might come across this when you're practicing. Now let's look into the second part on the next page. So same situation, but this time the books are distinct. Okay, they have their own value. Okay, so label them as M1, M2, and M3. Okay, similarly, I'm gonna have P1, P2, and then C1, C2, C3, C4, C5. Okay, same setup as before. I'm gonna have so you can kind of think about, I'll take red, this as open space, open space, open space, open space, open space, open space, and open space. Okay, so let's just focus on the math and the physics and the chemistry books first. So how can they be arranged? Well, this time they can be arranged 7 factorial ways. Okay, this is for the physics and chemistry. Okay, because now I can do 7 factorial ways and I won't divide it because they're distinct books, they're not identical. Okay, similarly, now I have 8 spots again and I have to fill in 3 of them, so I'm going to do 8C3. However, there's a catch. Because M1, M2, and M3 are distinct, they can be arranged in different ways as well within themselves. So let's say this is the spot they have picked for themselves. Now I can have, M1, M2, M3. I can have M3, M2, M1. That's different. And you get the idea. So since there are 3 of them, that is 3 factorial ways. Okay, so this is basically the selection of the gap, right? Selection of the gap, and this is arrangement inside the gaps. Okay, I have to count for them as well. Arrangement inside the gap. Got it? Okay, perfect. Okay, so now let's do another question. Again, with the imagination, but instead of bundling, we're now separating. Okay, so let's do the first part. So we're asked that the A's are separate. Okay, so again, let's list out all the letters. So we have the 3 I's, the 2 A's, the 2 N's, and then we have M, G, T, and O. M, G, T, and O. Okay, so these are what we have. Now, we are told that the A's are to be separate. Okay, A's are to be separate. Okay, so in that situation, I'm gonna have maybe my I, N, M, G, T, and O. So they can't be together. Okay, so I have one option here, 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 and here. Okay, again, let's solve for the non-A letters first. Okay, so how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are 9 factorial. Again, letters are the same, they're not distinct, so 3 factorial for the I, 2 factorial for the N. Okay, and then we have to basically allocate the A's. So the A's, they can go in any of the 10 blue spots, and I've just put 2 of them, so 10C2. That's it. This was my first case. Okay, let's see if I can squeeze in the second case here. In the second case, I'm asked to, let's say, wait, let me just see. Okay, I have 2 pages, right? So I'll do the second case here. Okay, so in the second case, I have no 2 I's are together. So it's kind of like the same situation as before. So I'll just set it up again. So I have N, A, and then M, G, T, and O. Okay, and my I's can go anywhere in between. I think now you're getting the idea, so I'll just be a little quick with it. So there are 1, 2, 3, 4, 5, 6, 7, 8, total 8 non-I letters, divided by 2 factorial and 2 factorial. And then I'm going to multiply it by, obviously, my 9C3, because I'm going to have to allocate the I's in these purple spots. Okay? Perfect. All right, next case. Next case is asking us 2 I's are together but separate from the third eye. Wow, that's pretty mean. Isolating the third eye. Okay, not an issue. So what we do now we have a case of bundling and separating. Okay, so we have 2 I's like this in forming one entity and another I like this. So let's list out the letters again. N, A, M, G, T, and O. And I'll change the color to blue for the empty spaces. Now note that in these spaces I'm going to fit the 2 I's as well, okay? So these spaces are basically for entities. Okay, so let's say this goes in this, and this goes in this. Now, same process before. We have 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial by 8 factorial by 2 factorial by 2 factorial. And then we have the I's, right? So we multiplied this with the 10 spots, or sorry, the 9 spots, and we do 9C2, okay? Again, I'm treating this like an entity, okay? So 9C2. However, now these 2 entities are different. This is like the 2 I's, and this is the 1 I, okay? So 2 I's and 1 I. So these 2 entities are distinct, okay? So they can be arranged by 2 factorial ways, right? In this case, I didn't do 3 factorial because the I's are all 1, 1 I's. Had they been, you know, let's say 3I bundle, 2I bundle, 1I bundle, then I would do a 3 factorial. Okay, I hope that makes sense. That's the reason why we're putting this 2 factorial as well. Don't forget it. That's also important. Okay, last and final case, which I believe is vowels and consonants are alternating. Okay, so let's list out all the vowels and consonants. So from the word imagination, I think we have 3 I's, 2 A's, and 1 O. So vowels are 1, 2, 3, A, and O. And the consonants are N, M, G, T. Okay, so they basically have to alternate. Okay, so we have how many? 1, 2, 3, 6 of them. And how many are there? 5 of them. Okay, that's it. There are more vowels and consonants. So remember, I'm gonna first fill spots for I'll fill the spots for the vowels first. Okay, so vowel 1, 2, 3, 4, 5, and 6. Remember, these vowels are not distinct. Okay, I'm considering them to be just vowels. They all come under the big tree or the big group of vowels. Okay, so I have the different vowels, and I have 1, 2, 3, 4, 5. Okay. Yeah, okay. And what I'm gonna do is I'm gonna put this vowel here, okay? And I will erase this because remember, the vowels and consonants both cannot be together, okay? So I'll change the color as well. So I have my C consonants like this. Got it? Okay, perfect. So now, let's say I have already allocated such spots. So this is for vowel, this is for vowel, this is for vowels. Okay, so there are how many spots for vowels? 1, 2, 3, 4, 5, 6. So total 6 factorial ways for vowels. However, there are 3 of the same vowels, so we have to divide by 3 factorial, because if I have I, and then if I just put this here, this goes here and this goes here, well, it's still I, you know? So I have to divide by the 3 factorial. Same goes for the 2A, so 2 factorial. And then for the consonants, so I have the 5 factorial for the 5 consonants, and the 2 N's are repeating, so 2 factorial, right? That's it. Okay, that's basically it, and this sums up the last part of this question. Okay, now we are to our next selection or separating question, which is, in how many ways can 5 boys and 3 girls stand in a queue such that no 2 girls are together? Okay, 2 girls cannot be together. Okay, so the 2 girls have to be there has to be a boy between one the two at least 2 girls. Okay, so let's write out the boys. Okay, so boy 1, boy 2, boy 3, and it's the first case. So boy 3, boy 4, and boy 5. Okay, so this is the first spot, second spot, third spot, fourth spot, fifth spot, sixth spot. Notice it doesn't matter if the boys are together. So that's why I'm considering all the possible options here. Okay, so let's say I'll take blue. Let's say this is the spot, this is one spot, this is another spot, and this is another spot. Okay, so let's look at the boys first. So we have, so there are 5 boys, 5 factorial, right? Again, I'm not dividing by anything because the boys are distinct. Now we're left with 6 spots for the girls. So the girls can go in the 6C3, and they can be arranged in those 3 spots, let's say in those blue arrows that I've drawn, so by 3 factorial ways. Okay, the 3 factorial ways. Okay, that's the arrangement. That's it. There's nothing more to it. Short and simple. And in the last part, we were told that exactly 2 girls are together. Okay, exactly 2 girls are together. Okay, so now should we bundle them up? How should we do it? Now this is the little bit of a tricky situation right here. Okay, so let's say we have 3 girls, right? Girl 1, girl 2, girl 3. Well, how many ways can they be bundled in 2 groups of 2? So this is basically 3C2, right? That's it. So there are 3 ways, right? So we don't care the order at the moment. We're not worried about the order of how they're bundled up, whether girl 1 is before girl 2 or girl 2 is before girl 3. We don't care about that. We're just caring about selection. Okay, so we have girl 1, girl 2, that's one bundle. Girl 2, girl 3, that's another bundle, and girl 3, girl 1, that's another bundle. Okay, so these are the 3 bundles we have. So this is what we have. Now these bundles, so if this is one bundle, we have girl 3 is isolated here, girl 1 is isolated here, and girl 2 is isolated here. Okay, so now let's list all the boys out again. Boy 1, boy 2, boy 3, boy 4, boy 5. Okay, purple, let's take for the empty spaces. Okay, let's take for the empty spaces. They can go in any sort of way. So before that, let's say they go in between boy 1 and boy 2, and between boy 4 and boy 5. Okay, this is one bundle goes there, and the other single girl goes between another set of 2 guys. Okay, so basically what we have is, first we have to put in 3C2. This is the creation of the bundle. Okay, creation of bundle. Okay, the fact that the bundle was created is just 3C2. Then we have our 5 factorial for the boys by default. Okay, then we have the 6C2, which is okay, I'll just write it. This is the boys. This is the selection of gaps, or I can call it gap selection. And then we have arrangement of the gaps. Okay, so 2 factorial will be arrangement of the gaps. Okay, so let's say this is let's say I'm taking this case for example. Okay, so here we can have girl 1, girl 2, or just the girl 3 alone, or we can have girl 1, girl 2, or just the girl 3 alone, that way. So this is the arrangement of the gaps. And finally we have to do the 2 factorial for inside the bundle. Okay, inside the bundle. Okay, so this is the final answer. I'm not going to simplify it because I don't really need to, but if it's in the calculator section, you can go ahead and simplify it. Otherwise, if it's in the non-calculator, you can just keep it as it is. It really doesn't matter. So yeah, that sums up the concept of bundling and separating. I hope this gives you better clarity and confidence in solving such questions. Alright, so this was all for this video, and I'll see you in the next one.